Assalamualaikum warahmatullahi wabarakatuh to Dr. Zinat and to all. So today our group are going to present about wall construction steel. Our group members are Ahmad Fatihin, Nur Idina, Alisha Daliana, Asha Sofia and Nurhayati. The table of contents, first of all, is definition, systems and structural systems, materials, joints, connection, detailing of the system. So first of all, I'm going to talk about definition. Structural steel is a popular construction material, often used alongside concrete to create impressive and long-lasting buildings. Its versatility, sustainability, and flexibility are some of the main reasons for its use, as well as being a very cost-effective material. With a high strength-to-weight ratio, steel can often provide a solution where other materials are unsuitable. So next is about system and structural system. There are different types of structural steel framing systems for buildings. One of it are skeleton framing system, wall bearing framing system, long span framing system. So first of all, I'm going to talk about the skeleton framing system. Skeleton steel frame is composed of steel beams and columns which are connected using proper connections. Steel beams around perimeter of the structure is termed as spandrel beams on which masonry walls are placed. Typical plan views of skeleton framing are shown in Figure 3 on the left side top and constructed skeleton steel frame are shown in Figure 4 on the right side on the bottom. Steel columns, primary and secondary steel beams are shown in the figures, those two figures. It should be known that all gravity loads in skeleton frame structure are supported by beams and columns. The distance between columns can be established according to the functions and requirements of the structure. Therefore, there are no restrictions that limit the area of the floor and roof of the building. Multi-story structures are possible to construct using skeleton framing. So next is about wall-bearing steel framing. In a wall-bearing steel framing structure, building wall, whether it is interior or exterior, is used to carry the end of structural members that support floor or roof loads. Wall bearing should be adequately strong to not only be able to carry vertical reactions but also to resist and impose horizontal loads. Wall bearing framing is suitable for the construction of low-rise structure. This is because the size of the bearing wall must be increased significantly to withstand considerably loads exerted in the case of multi-story buildings. There are several um, there are several cases in which wall-bearing frame systems is suitable to be used. For example, single-story house in which steel beams are used to carry wall and floor loads and the end of the steel beams are placed on foundation walls as shown in figure on the right. A further application of wall-bearing system application is utilization of steel beams, known as lintels, over wall openings like doors and windows. So next slide is about long span steel framing. Long span steel framing is considered when large clearance is required and such long spanning cannot be realized using steel beams and columns. Long span steel framing options can be categorized into different types. For instance, girders, trusses, rigid frames, arches, and cantilever suspension spans. These classes of long-span steel framing options, along with their applications and various configurations, are provided in the next slide. So the next slide is about the girders. So next is the girders. The application condition it is selected for the case where depth of the member is restricted over a large unobstructed area in lower stories. The girder should support loads from above stories across clear area. Various types or configuration of the given long span framing system class is roller beams, riveted girder, welded girder, heavy girder, hybrid girder, and a girder consists of two girder fastened. Next is a truss. For the application condition for a truss, it can be used for the case where restriction on the element depth is not imposed. It an economical way of spanning long distances, provided that depth limitation is not existed. Trusses are better compared with other options in controlling the flexions due to better stiffness. There are various types of or configuration, which is Pride, Warren, Fink, Scissor, bowstring, and virendale. These are the four different types of trusses used in steel structure construction. So next is the arches. Application condition, it is used to carry walls and roof with open or solid web arches. Next is various type or configuration, which is hinge, less arches, two hinge arches, and three hinge arches. The above picture is types of arches used for steel structure construction. Next is rigid frame. The application condition it is lead is used to span long distance. Is aesthetically pleasing that is why applied in the construction of churches, gymnasiums, auditoriums, bowling alleys, and shopping centers. Various types or configuration of the given long span framing system class is single span rigid frame, welded rigid frame. The left side of the picture is the single span rigid frame.
The next I will explain about the material. So the material steel usually used in construction is first is light gauge steel. It is made from thin sheet based on specific standards, easily workable to make a steel frame system with good deformed steel. The steel is shaped by a good working process. Light gauge steel joists and studs are readily available in shop. It is flexible and safe and also environmentally friendly choice using recyclable materials. Next is structural steel. Structural steel is one of the popular type of steel used in construction. It is used mainly to give a base or structure to the building, used for developing the structure, available in different specifications and shapes like T-shape, channel section, I-beam, plate type, bar or rod type, and etc. And also laser of construction time. Next is mild steel. It is a plain carbon steel known for its strength and the most commonly used steel for construction. Used for both conventional and modern pre-engineered buildings. This steel can be bent, cut, and twisted to create the desired shape easier and is more lighter than other steel. The last one is rebar steel. It reinforces steel, reinforces the structure fusing well with concrete, also used in the form of a mesh of steel wires for building purposes. Wood round carbon steel bar are mainly used. Its improved tensile strength and it can be manufactured to very long lengths. Next is about the column. There is several columns that are found. First is spiral reinforced concrete column. Spiral reinforced concrete columns are concrete reinforcement column with an embedded steel mesh which is called a rebar that provide reinforcement to the column structure. The spiral of the column provide transverse support across the width of the structure. Secondly is a short reinforced column. This column have a slenderness ratio of less than 12 inches and they contain steel bars. Short reinforced column have some flexibility and the loads they support vary and depends on factor like their strength. Next is top column. This column rests on slab rather than foundation footing to provide additional support. Uh, and the next one is the tension column. Tension columns are made from steel, concrete, and other materials. These type of columns are not commonly used type of column in construction. Next is square or rectangular column. It's classified based on their shape. Square or rectangular column are easy for shuttering, placing reinforcement, and concrete pouring. It's combined with their general affordability, makes this type of columns a popular choice among the others. And the last one is L-shaped column. It is easy to construct and case, and the level of support they provide often make them a best choice of best choice of column for building and other heavy structure. Next is about the beams. Uh, First is the angel beam. Angel beam is also known as L-shaped beam. Have two legs which have equal length that joins to create a 90-degree angle. Second is C-shaped beam, also called as C-beam or structural C-channel. Uh, it is a feature of C-shaped cross-section with top and bottom flank connected by a web structure. Next is bearing pies. Bearing pies have a hinge shape to transfer loads to provide a deep foundation system if a structure cannot have a shallow foundation. Other than that is T-beams. T-beam has a T-shaped cross-section with a flank and a vertical web, and they can withstand a large load. Next is universal beams, also called as H-beam or I-beams, include two horizontal elements called flank. These allow them to resist bending movement because they are connected by a vertical elements or web that resist force. And the last one is S-shaped beam, or called as American Standard Beam. have a web connection between a roll section and two narrow flanks parallel to one and another. So that's all for materials.
So now I'm going to present about joints for our construction steel. What is joint? So basically, a building joint is a junction where two building elements come together without transmitting a static load from one to the other. When one or more of these intersecting vertical or horizontal parts is required by the local building codes to have a fire resistant rating, the resultant aperture that forms the junction must be fire stopped to restore the requisite compartmentalization. So there are five types of joint in wall construction steel that I have found. The first one is butt joints. Next, lap joints. The third one is T joints. Next is corner joints, and lastly is edge joints. So the terms weld joint design refers to way pieces of metal are put together or aligned with each other. Each joint design affects the quality and cost of the completed weld. Selecting the most appropriate joint design for a welding job requires special attention and skill. So the first one, we go through the butt joints. A butt joint, also known as a butt weld, is a joint formed by placing two pieces of metal in the same plane. A weld and welding the side of each metal together. The most common type of joint used in the fabrication of structures and piping system is a butt weld. It's relatively simple to make, and there are numerous variations that can be used to achieve the desired results. So here the picture of the butt joint, and there are six examples of butt joint, which are square groove, V groove, bevel groove, flare V groove, U groove, and J groove. So next, the lap joints. Lap welding joints are essentially a redesigned butt joints. They are made by stacking two pieces of metal in an overlapping pattern on top of each other. They are most commonly used to connect two pieces of varying thicknesses. Weld can be done on either one or both sides. So here is the picture of lap joints. So there are also six example of a lap joint here, same as the butt joint, which is fillet, J groove, bevel groove, plug, slot, and spot. So next, the T joints. When two pieces intersect at a 90-degree angle, a T welding joint is formed, just like in the picture given. As a result, the edges of a plate or component form a T shape in the center. T joints are a type of fillet weld that can also be formed when a tip or pipe is welded to a base plate. So there are six examples of T-joint, which are fillet, J-groove, bevel groove, plug, slot, and flare V-groove. Next is the corner joints. Corner welding joints are similar to T-welding joints. The difference, however, is the location of the metal. It is placed in the middle of the T-joint, whereas corner joints meet in the corner in either an open or closed manner, forming a L shape, just like in the picture given here. So there are eight examples of corner joint, which are square groove, fillet, J groove, V groove, spot, edge, corner flange, and flare V. So lastly, edge joints. The metal surfaces are placed together so that the edges are even in an edge joint. One or both plates can be formed by bending them at an angle. The purpose of weld joint is to join parts together so that stresses are distributed. Tensile, compression, bending, torsion, and shear forces are
all causes stresses in welded joint. So there are seven example of edge joint, which is edge, bevel, V groove, J groove, U groove, corner flange, and edge flange. So that's all for joints. Next, connection.
Next, I will be presenting about steel connection. So what is steel connection? Connections are structural elements used for joining different members of a structural steel framework. Steel structure is an assemblage of different members such as beams, columns, which are connected to one another, usually at member and fastener, so that it shows a single composite unit. So what are the components of a connection? First one is bolts, weld, connecting plates, and connecting angles. Let's move on to classification of connection. The first one is connecting medium. In modern times, the most common types of connecting mediums are welds and bolts. Welds offer simplicity, while bolts offer economical installation in the field. Rivets have historically been used, but have been mostly replaced by bolts for a number of reasons. These include riveted connection, bolted connection, and welded connection. Next, internal forces. One of the most important considerations when designing a steel connection is to design based on the internal forces that the connection is expected to transmit. Connections are classified as axial, shear, semi-rigid, or moment. Rigid connection based on the primary load that the connection is to carry. Connections, however, are most typically expected to carry two or more of these loads. These include moment connection, shear connection, and axial connection. Next, move on to types of structural elements. The types of structural elements that make up a steel connection is a common classification. There are so many different types of structural elements, and the various placements to the structural members results in many different connection types. The most common structural elements are angles and plates. Angles can be placed at an I-beam web, or known as web angle, or at the I-beam flange, seat angle, and plates can as well in a similar way, resulting in web plates and flange plates. Next, moving on to members joining. The classification of steel connection is also commonly made to the structural members that there are to connect. In fact, the consideration for connecting columns and beam should act as one of the primary considerations when needing to design a steel connection. The common configuration include beam to column connection, beam to beam connection, column to column connection, column base plate connection. And moving on to steel beam connection. Steel beam connection are categorized into two groups, namely frame and seated connection. In the frame steel beam connection, the beam is connected to the supporting steel element through fittings, whereas in case of seated connection, the beam is positioned on seat, similar to the case where beam is placed on masonry wall. Next, moving on to types of steel beam connection. The first one is bolted frame. In this type of connection, steel beam are linked to supporting elements, whether it is steel girders or column with wet connection angle as seen in the figure. Next, moving on to bolted seated type. There are two major types of bolted seated connection, including unstiffened bolted seat connection and stiffened bolted seat connection, as illustrated in the figure. Moving on to welded frame. Like other two types of beam connections, various sizes of welded frame connection with their capacities are available and provided by codes. The weld of the connection is subjected to direct shear stress and stress caused by loads on the beam that affect weld pattern. So these stresses are required to be considered. Moving on to welded seated. It is similar to bolt seat connection, but welding is used for fastening rather than bolts. The loads on the beam affect the weld pattern eccentrically and generate stress. So, like welded frame connections, stresses need to be considered. Types of welded seat connection include unstiffened seat and stiffened seat. The former is used in the case of small applied loads, whereas the latter is suitable for case of large load. It is advised to use bolts to connect beam bottom flange to the seat. These bolts can be removed or left at their position after the welding process is ended. Welded connection is not desired from environmental point of view and worker. This is because such connection is neither can be dismantled or erected easily. And lastly, the end plate. This type of connection is made possible through the use of welding art. The end plate is connected to the beam web through weld because its capacity and size is governed by shear capacity of the beam web adjoining the weld. The load applied on the connection at the end of the member does not have eccentricities, so there are different types of end plates connection, including flexible, semi-rigid, and rigid end plate connection. It should be known that fabrications and cutting should be conducted with utmost care to avoid errors. For example, cutting the beams to length must be accurate as possible. Finally, end plate connections are not suitable for tall steel structures. That's all for connection.
Okay, so now I'm going to present about detailing in system for wall construction steel. So the first one, we have window and curtain wall system have their own lateral load bearing structural structure. The millions of glazing system offers support for transferring the outside wind stresses on the glazing to the core building structure. So generally, depending on the size and orientation of the glazing covers the short path between millions horizontally or vertically. So next, the tools used for wall construction steel. What we have here is plasma cutting system. It used to melt and expel material from the cut. Next is impact drill, uses rotational force to drive a screw. The third one is circular saw, used for downsizing, trimming, or other cut off. Uh, Next is metal bandsaw machine, designed to cut large carbon steel, stainless plates, slabs, blocks, and ingots. And lastly is screw gun, specifically used only for fastening screws and not designed to drill holes. So I guess that's all from our group, Wall Construction Steel Group. Thank you.